Hello, this is Alan Lewis. Just a follow-up video. This is my code for my um, solenoid launcher. Basically, the uh, beer pong launcher in the previous video. So, just gonna go over the code. It's kind of straightforward with all these comments. If you're viewing this on Instructables, the the code is there. Like I linked the file, so and I'll link it in the description. So let's get into it. Alright, so first, you need this servo.h file to actually control the servos. Here's all my pins set up. It's not that, it's kind of just self-explanatory. You can change them to whatever you want. I use all of these, so you don't have to hard code anything. This is a good, here's two servo um, variables. I use them interchangeably so they can be controlled independently. Initialization of all my variables. I set this as 100 because a while loop that I have has that parameter before beginning. These are just coefficients. We'll see that later. Gravity, empirically calculated initial velocity. This is for the dynamics of the projectile. This was just found by launching the solenoid several times at 45 degrees, measuring its max distance, and that's the only thing you have to solve for. Kind of need pi because when you do a sine of something, it does it in radians, so you have to convert it to degrees for the servo. These angles, as you can tell, they are not 45 and not 0. So, in essence, I designed this so one servo is on one side, one is on the other. They're rotating opposite. So one servo is going from a 0 to 45 degree angle and counting up. So you need one angle at in that range to go up. I initialize it at 36. Doesn't really matter, but it all depends on how you assemble it. The other one counts down, so you need that in this range, 45 to 90. These are just more variables, pretty straightforward. Make sure you start your serial communication so you can actually print stuff out on the serial monitor right here. I'm not going to do it because it's not connected to anything. This is for the sonar sensor. It's just initializing one as an input, one as an output. This one is the button that actually starts. This is the button that starts the actual loop. You see that down here. Here is the servos. So as you can tell, the right servo initializes at, that's the pin. Yeah, that's the pin. And then it initializes at 36 degrees. So this is kind of just a arbitrary arbitrary like comment, because I did have it at 42, and then I realized when I measured it, when I built it, put the new brackets on, it wasn't at 45 degrees, so I had to reinitialize it and just -6, and the launch was at 45 degrees. Here is the other servo. It starts at 56 degrees, and then the pin for the solenoid is, it's just an output 'cause it's just a switch with how it's wired. Alright, loops. This is where the magic happens. So basically, the button in the back, if you're viewing this on instructables, you'll see it. You press it, it starts everything. So it delays it 1,000 milliseconds. So basically, you're waiting a second, and then you're starting to gather all the distances that you need. The reason for that is if I didn't have this in there and I pressed the button, I mean, there's only a 12 microsecond before what is it? Oh yeah, 24 microseconds before you actually have an if statement if you press the button again. So kind of need that delay. I mean, you don't want to hold the button down. So this distance was at 100 up here. So it's like while it is over 60, it reads a distance and then initializes this, converts it to centimeters right here, 58. This is just the steps it takes for the sonar sensor to get a pulse. After that initial distance, you do a for loop. You take 10 more measurements. If they're in the range, nothing happens. I mean, it's just added because they're summing right here. But if it's not in the range, which this says, like this is distance 2, which is this read. Distance 1 is up here. So if distance 2 is like outside 10 centimeters, it just adds it in as 0, but then it redoes the iteration. And then the only problem with this is if you take an initial distance and it's like, I don't know, it just doesn't read it right, because some sonar sensors just read it and it's terrible because it's just a sonar sensor. It sucks. I would definitely recommend using an IR sensor if you're trying to replicate this. So IR sensors can pick up pretty much anything, honestly. And if it does, it reinitializes, like this is IS10, so it exits the for loop, and then it says shoot at 0. So you'll see that in the if statement down here. It just makes it not shoot, basically. And then count equals 0 to exit this top while loop right here. So after that, I mean, it sums them. It divides it by 11 to get a running average. Just it displays it for you. It displays it, like I have a lot of displays right here. So, and then initializes R as your distance, converts it to meters, and here's my optimization curve. So that's where this comes in. So this measurement was basically 0. This measurement, so I put the cup, this is in meters, so 11 centimeters away, and then 55 centimeters away, and at 11 centimeters, it fired it, and it hit, it needed to hit something. I'm sorry, let me rephrase that. Alright, this is actually what it's measured. My bad. Alright, so this is landed, and this is measured. Probably should have done this before I started recording. But anyways, so it measured 0.1, and then it measured 10 centimeters, right? And then it moves up. I mean, if you're looking at it, it moves up, and it goes to about 80 degrees maybe, and then it lands basically on top of the sensor. So that's at 0. This one, it measured 20 centimeters. Measured the cup was 20 centimeters away, I think, and then it landed short because the ball moved. And then it measured 55 centimeters, and it landed actually 55 centimeters. So these are all measurements, and that's where it actually landed in the cup. Like this is where it landed. So this is the actual curve. So basically what it's taking is if it measures it as if it measures it at 0.1, it needs to be at about 0.19. That's the actual distance that it uses in this formula, because it needs to accommodate for the ball repositioning when it goes up an angle, because it goes back too. It goes back and up. So, I mean this this was like 19 out. After I did this, was it it landed like 19 out of 20 times if you aligned it right. So here is here's just the distance formula. It didn't really like when I put all of this in one line, so just did it in two separate lines. Alright, so right here, so this calculates a distance. This calculates like the distance that you need for the formula. And if that distance is over 60 centimeters, which is over its max distance, it's just going to try at 45. So basically all of this is not going to move. And it's just going to try. Because, you know, why not, right? Alright, so you may wonder why I have 81 right here. So this basically sums it up. Since my angle up here, initializing, was 36, it's 9 above, or I mean sorry, 9 below, it's 9 below 45, so 9 below 90 is 81, and then it just resets right there, so it has to go up. So this angle theta is going to be from 0 to 45. It's not going to go above 45 because we don't have any negative angles, I think. Or it's just the way the formula works. It's not going to go above 45 because the formula is sine of 2 theta in the actual max distance formula. So, I mean, 2 times 46 is a negative distance if you take the sine of it. So, anyways, that may not make sense, honestly, but like, if you logically think about it, it makes sense. So this gives the position for the one on the left, the servo, and then this one gives the position, the person of the servo on the right, or vice versa, whichever one you, if you did it like mine, then this is what it's gonna be. So, alright, so right here it just says if shoot is 1. So back up to here. If you press the button because it's not doing anything for a while, it just resets. So if shoot is 0, it doesn't shoot at all. It just skips this, and then skips this. Does it? Yeah. Because this is all in the if statement right here. So this while loop it just positions both servos at the same time, with a delay, so it's, so it doesn't jerk up there. So then it waits 2 seconds. Solenoid fires. It's just a switch. I put 50 milliseconds on there. It doesn't really matter how long. I wouldn't put it too long because it just literally just needs a pulse. So if you put it for too long, it's probably gonna warm up, and you really don't want that. After the solenoid fires, it waits another 2 seconds, and then then these servos just go back down. Pretty much same way it goes up. And then you just reinitialize everything. So this count equals 0, exits the while loop right here, and then This distance is the sum. This is actually the sum, and then shoot is 1 when you go back up. So that way when you reinitialize, shoot is 1. So it's gonna expect to shoot every single time. But in the case that if you press the button, it doesn't shoot. I think that makes sense. So, anyways, yeah, this is my code. I mean, have any comments or questions? Just, leave a comment. You know, whatever, man. This was a fun little thing, but it was a bitch to actually get it right. So, yeah, so long.